Hello everyone. Today I'm going to show you how to start up with the Schematic Manager. Just, you can see I'm having the Schematic Manager icon here. I public open this. So we're going to see how to configure using simulation. Okay. I open the previous. First, go to the option here. Select set PG or PC interface. PG or PC is actually your PG stands for programming device, and PC is our laptop or PC, whichever we are using for programming. Okay. Open this. Here you can see it has different types of drivers here. Here you can see Qualcomm Atheros, this is for your Ethernet card when you are using Ethernet protocol for communication. For that you need to use this TCP/IP. Okay. Otherwise, if you are not using hardware, in such case you can use PLC SIM. If your CPU is having Ethernet port, then you can use your TCP/IP, or if your CPU is not having Ethernet port, you can go with the PLC SIM MPI. Okay. Otherwise, if you are using hardware, using MPI adapter, for that when you connect the adapter, it will display you the PC adapter. Okay, it will automatically detect the driver. Okay, then you have to select that driver. So here I am showing you with the PLC SIM TCP/IP. So okay, now so once you select this PLC SIM TCP/IP, at bottom you can see it is showing the driver name. Okay, so here it shows you whichever driver you are going to use for communication. Okay, you should uh, check this driver name before starting your program. Okay, first configure this using set PG/PC interface. Okay, now then go to the file, new. Here you can give any name, like your project name. For example, I'm giving the name as example one. So okay, so it has opened your new project. You can expand this window. Right click on this project name, go to insert new object. Here we are going to work with Simatic 300 station. Okay, so this is 300 station. So you can give the name of this PLC, like a PLC1, PLC2, any name you can mention. Then double click on the icon that is showing hardware. Okay, so when you double click on the icon, the same name is showing below the project name. Okay, so here double click on icon of hardware. This window is opening. SW config. SW config means hardware configuration. In this window, you need to configure the hardware available with us. Okay. So here you can see in this hardware configuration window, I'm having three partitions. This partition is known as, first one is known as configuration window, below is known as details window, and that one is known as catalog window. Okay. So from catalog, we need to select our modules because it is having the list of all the modules which are available in Siemens. Okay. So out of this, you can see we're having, when I expand Simatic 300, we are having many modules. Out of this, first we need to select the rack. Rack is actually a rail on which we have to mount a 300 system. We select the rail, drag and drop here in configuration window. So when you drag drop this rail, combination of numbers it is showing here, these are called slot numbers. So 1 to 11. 11 modules you can configure in this one rack. Okay, below also it is showing you the details with the module number, order number, firmware. Firmware is like the OS of your CPU. Okay, OS version of your CPU. MPI address, I address starting from, Q address starting from. Okay, then slot number 1 is for power supply. Here you can select any power supply module. Okay, any means like as we are doing with the simulation, you can select any module. Okay, if you are having any hardware power supply module, what is a power supply module? This is actually a converter, means it is converting 230 volts AC to 24 volt DC to power up your CPU and IO modules. Okay, so here we are having 5 amp, 2 amp, and 10 amp IO modules. So here, if we are having a single CPU, so 2 amp module is enough. If you are having some IOs with that, you can go with the 5 amp modules. Okay. If I'm having all the modules here in the rack, more than 6-7 modules, so we prefer 10 amp module. Okay. And one more thing here is not necessary. Okay, to configure power supply module because this power supply module is not communicating with CPU. It is just powering up your CPU. Okay, in 300 system. So it's not mandatory, so I can make it blank, keep it blank. Then I go to slot number 2, expand CPU 300. Out of this, you can see we are having many CPU ranges, CPU type 312, 313, 314, tablet up to 319. Here we are having different types of CPU. C is a symbol of compact. Compact means some integrated IOs are available with the CPU. Integrated means just like if you compare with PC, PC like which is having a big monitor, right? Separate CPU unit, separate mouse, separate keyboard, right? If you compare this system with a laptop, the laptop is having all integrated system like a monitor, keypad, mouse. These are all integrated in one system. Okay, that is your laptop. So here also in this type of CPUs, we are having some integrated IOs, inputs and outputs, not power supply. Okay, only inputs and outputs. So it will be like 8 inputs, 8 outputs, 16 inputs, 16 outputs, like that. Different combination CPUs are available. So here, as I have selected protocol for TCP/IP, so I'll go with the PN type of CPU. Here you can see PN means Profinet, okay, which is having Ethernet port. You can expand this 314C 2PN by DP. C means again it is having some integrated IOs. So expand the same folder here under that. Now here this is just CPU symbol. You can drag and drop this version 3.3, which is a firmware version, or you can say OS version of PLC CPU. Now, here in this, it will once you add this CPU here, it will ask you the IP address of your CPU. So here you can select IP address 192.168.0.1. Okay, so this is coming by default. If you want to change, you can change also. Okay, but you need to add one subnet. This is a network driver for communication. So okay, okay, this will be added to the CPU. Okay, so you can see X1, X2. X1 is for MPI by DP. MPI by DP is another protocol. Okay, multi-point interface, and DP stands for decentralized peripheral. MPI is for PC communication and PC PLC and HMI communication. You can use DP is for remote IO communication. Okay. Now, so here this X2, it is having two ports, port 1, port 2, means two Ethernet ports are available on this CPU. This again you can see DI24 by DO16. There are 24 digital inputs and 16 digital outputs in this. And AI5 by AO2 means 5 analog inputs and 2 analog outputs are available. Okay. Then you can see one more option is count. Count means here you can use this CPU for high-speed counting application also, because these compact CPUs are very much useful in such application, high-speed counter. Okay, so no need to add any additional high-speed counter here. Just save and compile this hardware configuration. And one more thing here at bottom, you can see here in the details window, it is showing the I address and Q address. For I address here, it is starting a byte number from 136 to 138. Okay, so these are called byte numbers. One byte means 8 bits. Each bit, one bit means what? 0 or 1. Okay, status 0 or 1 means 1 means on, 0 means off. Okay, so 8 3 are 24. So here we are having 24 digital inputs. Similarly, for 16 outputs, digital outputs, we are having 136 and 137. Suppose if you want to change the byte number, you can change it, double click on DI24 or DO16, go to the addresses, remove the system default, make it to 0. This is optional here for simulation. Okay, you can directly use 0 and 0, 1, 2, 3 byte numbers. Okay, but when you are doing with the hardware, then you can change this. Okay, not an issue. So run compile again. Then I need to download. So before downloading, we need a source, right? For that, go to the Schematic Manager. Here you can see we are having an icon here on the toolbar called simulation on or off. You can click on this button to start a simulation here. You can see it is showing a different small windows here with CPU, inputs, outputs, and bit memory. Here you can see it is showing the CPU indicators for run status, stop status, fault status, etc. So always keep this to run P. Run P means run program mode. Okay. If you keep this in run mode only, you cannot download any program after modifications. So you keep this in a run P mode until you make any modification practice. Okay. So always keep this in run P. Here IB means input byte number 0. The first byte number which is having 8 bits again 0 to 7. Similarly here for the outputs 0 to 7. Okay. Let's minimize this one. Then go back to hardware configuration, and then you can see on toolbar we are having download to module option. Click on this. So, okay. It is showing a module tab CPU at 41 because we are using simulation. Okay. Just say we detect our CPU. It is not detected, not an issue because it is not downloaded yet. So, okay. The following modules will be stopped for loading of the system data. Means your CPU will go to the stop mode. If it is in run mode, it goes to the stop mode. Whenever we download hardware configuration, the CPU goes to stop mode. If we are downloading program blocks, in such case, the CPU does not go to stop mode until there is an error in the program. Okay, that's the difference. So, okay. We want to start a module now. That's a complete restart. Say yes. Now, the download hardware configuration is downloaded. So minimize this and go back to Simatic Manager. And this expand your project. can see CPU 312, sorry, 314C2 PN by DP, and that's S1 program. Under that, go to the blocks. Here you can see two files, one is system data, another one is OB1. System data is like your hardware configuration. So this file is generated whenever you are doing hardware configuration and save and compile. Okay, you must do this. Okay, and you should read this folder. Okay, by save and compile option. Okay, now double click open OB1, which is your main program block, which is executed according to your CPU scan time. So here in this properties, it is showing you some details like created in language ladder, or if any other language you want to use like SQL or FBD, that also you can select. This is the date created and last modified date, etc. So okay. Now in this you can see we're having networks as we're doing the ladder logic. Ladder means it is having some steps. Okay, so these steps are executed one by one, step by step, from top to bottom, left to right order. So here we call them as networks. Like this. So you can add up the networks by clicking on this new network option, or you can double click on this option also, new network. Here you can add up more. So now we are having these symbols here, and no NC output coil. Okay, you can select from here. You can do the address I0.0 0.0. Okay, so you can download this program from here, and you're having this monitor option. Okay, you can monitor the logic by clicking on this monitor on off button. Now this is online. The simulator. You can open the simulator. Now you can see here I address I0.0, byte number 0, bit number 0. Here also byte number dot bit number. Okay. Now this is your simple logic, like a switch. If you are having switch means you can toggle it on and off. If you keep the switch in on position, your input will remain on continuously until you make the switch off. Okay, with that your output will also remain on. In case if you are using a push button means it's a momentary switch. Means when you press, it becomes on. When you release the button, it goes off. Right? It comes back to the original position. So that becomes zero. Right? But when I press the push button and release, your output should remain on. Okay, should hold. For that, we need to use latching here. Okay, latching is used for holding your output. So select before your input. We can add a rung. Okay, here means a branch we have to add up. Select this button, and then select a normally open. So here Q 0.0. Checking online. So like you just start input here. Output is on. If I release the button, your input goes status goes off. You can see output is still holding on. Even if I do the same input again, is it stopping? No. Right? We need to break this continuity. Okay, there is a continuity in here, so we need to break this continuity. For breaking that continuity, what we have to use? We have to use one NC here. I'm using NC for stop because I'm using my second button, that is stop, for as a NC. okay, as a NC, sorry, NO. Okay, this is open contact. Okay, so when you select this will be one. Okay, this will be closed. So I'm using it as a NO. Okay, so that's why here I'm using as a NC. Now I download this and monitor. Now when I click on this NO, this will open, right? It is breaking the continuity here. And when I reach the button here, push button, again it come back to the original position. Now you can see for start, this for stop. Okay. Now this is the normal latching circuit. Okay, for holding your output using push button. Okay. Now if we are going to connect with SCADA, here we need to create one shared DB. Okay, one DB block, which is internal memory. Okay. I click this for SCADA purpose. Okay. Insert new object. This will hang different types of blocks. Out of this select data block. DB1, take it as a shared DB. We'll discuss these topics further. Okay. So I give name like PLC, SCADA, okay, and some name. So okay. Now just created one new block here, DB1. Double click open this. Opens here. Here I give like start, which I type as bool. Waiting only for start and stop here because we can read or write output address from SCADA, but input we cannot write from SCADA. Okay, so for input commands from SCADA to your PLC, you need to create this start stop using DB memory. Okay, so I save this file and we need to call this in the OB. Open OB1 now, and here for start in parallel to your input like PLC, you just enter P here to show you the name. Okay, DB name which we have created. In this select this start. Then for stop command, stop. So it will automatically create the address here. Take the address db1.dbx0.0, db1.dbx0.0.1 for stop. Okay. Then save this OB1. So do not download from here. Go to Simatic Manager. Select both the blocks OB1 and DB1 because this block is created separately. Okay, in blocks. Okay. So you need to select both the blocks and download from here. No need to select system data again. Once you are downloaded hardware configuration, you no need to download it again. Okay. Yes. Yes. Now go to here for operating your DB address. You can simply right click on this, click on modify. You can see again as a push button, right click on modify to 0. Modify to 1 means on, modify to 0 means off. We stop here, right click, This way you can operate from here. Okay. And once you connect this with SCADA, from SCADA we get the signals here, which is this video already I have posted SCADA PLC SCADA communication. Okay, in my channel, you can check with that also. So this